This is Mr. Martin. This is the video notes for section 2.1 on perpendicularity. So let's take a look at the definition. We've got if lines, rays, or segments are perpendicular, and notice the symbol I have here for perpendicular. It's like an upside down capital T. Feel free to use the symbol anytime you would use the word perpendicular. Then they intersect at right angles. And then we have the converse. If lines, rays, or segments intersect at right angles, then they are perpendicular. So keep in mind here that use whichever of these figures is appropriate for your proof. So you don't need to use all three every time. You only want to use the one or the two that are appropriate for that problem. Okay, so the symbol form for writing that AB is perpendicular to CD. Notice we just put the two figures and we put the perpendicular symbol in between them. And then our important note here is that since we cannot assume right angles, and perpendicularity is based on right angles, we cannot assume perpendicularity. Cannot assume perpendicularity. Has to be proven. Alright, so just one new definition for today, so let's take a look at some examples. If at any time you want to give these a go on your own, feel free to pause the video and see what you can do and then restart the video to check. So for example 1, we're given that AB is perpendicular to BC, and a lot of times what I'll do is when I see perpendicular, I'll mark it in my picture with a right angle marker. And then just be careful, even though you've drawn the right angle marker in here, if you want to use that as a right angle or 90 degrees, you still need to do that in your proof. For this, it's an algebra type problem, so we don't really have to worry about it. I'm just getting a visual in the picture. So I know that angle ABD is 4 times more than angle DBC. So I know that angle DBC is smaller, so I'm going to let that be x. And then since ABD is 4 times more, I'm going to let this angle be 4x. And then again, since these are perpendicular, I know that this angle forms a right angle, which means it measures 90 degrees. So I know that 4x plus x is equal to 90, which means that 5x is equal to 90, which means that x is equal to 18. And once we have that x is 18, I can find the measure of angle CBD. That's just going to be 18 degrees. And the measure of angle ABD is going to be 4 times 18, or 72. Actually, I don't need the degrees over here if I'm going to have the m. Okay, so there's our two answers. As always, if you have questions, I would write them down in the margins and then check in with me when you get back to class. Alright, looks like we have a little spacing issue here, but that's okay, we'll work with it. So for this one, we're given that EF is perpendicular to FG, so again, I'm going to make a little right angle mark here. And I want to prove that angle EFG is a right angle. So this is one of those problems where it's just a two-step problem, so we're not going to really set up a two-column proof, but if we did, the first step would be EF perpendicular FG, and my reason would be given, and then step 2, I could state my conclusion. So again, feel free to pause and see if you can write down the correct reason. If segments, because we're given two segments up here, are perpendicular, then they intersect at right angles. Alright, so moving on to example 3, we've got the same picture. This is point F, this is point G, and now we're given that EFG is 90, so we want to prove that EF is perpendicular to FG. So we're going to do a two-column proof, so I've got statements, I've got reasons, go ahead and put my given information, angle EFG equals 90 degrees, given. Now, this is one of those cases where you have to be really careful, because saying that an angle is 90 degrees and saying that it's a right angle, they are so close, but they're not exactly the same. And our definition up here says if angles, or if lines, rays, or segments are perpendicular, they intersect at right angles. So my definition and my converse, they talk about right angles, but they don't talk about 90 degrees. So in order to use that definition of perpendicular right now, I need to first say that angle EFG is a right angle. So if an angle measures 90 degrees, then it is a right angle. Okay, is that a definition or a converse? You should be able to answer that. Now that we have that EFG is a right angle, I can see that EF and FG, since they're a right angle, that these two must be perpendicular, and now I can state that EF is perpendicular to FG. Okay, and again we have two segments, so if two segments intersect at a right angle, then they are perpendicular. And we'll talk about an alternate form at some point that will make this a little bit shorter. But if you have some suggestions, let me know in class. Alright, example 4, moving on. Again, we're going to do a two-column proof. So we have statements, we have reasons. If you want to give this a shot on your own, feel free to pause the video. Always a good idea to see what you can do on your own. So I'm going to go ahead and put my given information here. RT is perpendicular to TC. RT and TC. So I'm going to mark that. Given. And I've got RE perpendicular to CE. I'm going to mark that. Given. RE and CE. So I've got that. And I want to show that these are congruent. So again, we know that when segments are perpendicular, they form a right angle. So I can say from the first given that angle RTC is a right angle, and I'm going to use my definition of perpendicularity. If segments are perpendicular, I'm going to write a slightly different form here, which feel free to use. They form a right angle. So instead of saying they intersect at a right angle, you could just say they form a right angle. That's perfectly acceptable. Then I'm going to do the same thing with the second given. Since RE and CE are perpendicular, and I didn't really have to use 3 letters here, so I'm not going to use 3 letters for this one. I know that angle E is a right angle. And the reason is the same as reason 3, so we're just going to say same as 3. And then now we have that these two angles are both right angles. And what do we know about right angles? We know that they are congruent. So angle T is congruent to angle E. That's angle T over here. Because if angles are right angles, then they are congruent. Alright, so proofs are going to start getting a little bit longer. You know, and I encourage you, if you have any trouble at all, come see me for help. You know, usually 5 or 10 minutes we can get things straightened out, and the sooner you figure out your two-column proofs, the better off you're going to be. We're going to be doing two-column proofs all the way through first semester, and then about halfway through second semester, so they're going to be very important for us. Alright, we'll see you in class.